In this video, we'll be discussing the risk control step in our generic risk management model. Step 4 in our risk management model is risk control. At this point, you will have identified the problems and opportunities. You will have accomplished all the risk estimation tasks for risk management, and your risk assessment team will have completed a risk assessment and other evaluations as needed. You will have evaluated the risk, and if you make a decision that the risk is unacceptable and requires some risk management, then you would move on to the risk control step. We're going to take a look at the first of those 6 tasks, formulating risk management options. Even though this occurs in step 4, as a practical matter, you may begin formulating risk management options from the very outset of your risk management activity. Frequently, if we are going to initiate a risk management activity, you already know that there's going to be a need to take some action. That won't always be the case. But whether it is the case or not, in step 4 is where you would formally begin to look at the formulation process. We're going to refer to the practical example of our case studies in this little mini lecture. So when we begin talking about formulating risk management options or alternative plans for addressing risks that are unacceptable, it's important to understand that the work that you've already done to this point in time is very important. The objectives and constraints that you identified will lead the way through this risk management formulation process. We're going to focus primarily on the qualitative case study of the aquatic nuisance species. So when we formulate risk management options for these, we're going to take a look at 2 broad sets of measures. There are non-structural measures and there are structural measures. The terms are practically self-explanatory. Structural measures are things that must be built, constructed, or otherwise implemented. Non-structural measures are different ways of doing things or softer kinds of solutions. By now, you'll be familiar with our aquatic nuisance species issue, and so we'll move directly into the consideration of some of the non-structural measures. Measures are features or activities. A feature is a physical component. An activity is doing something or doing something different. So when we talk about non-structural measures, we would be considering both features and activities. For the Glimmerous study, the team identified technologies that would be available for the potential control of some of these aquatic nuisance species here. You see, this fact sheet that you have is divided into 2 parts. On the left-hand side, under the heading Fact Sheet, you would see some broad categories of non-structural measures: algicides, aquatic herbicides, biocides for industrial use, and so on. To the right are more specific examples of these particular measures. So the team considered some 90 plus technology measures, as well as some standard kinds of non-structural measures such as education. What I would like you to understand, though, is it's the risk manager's job to be as comprehensive as you can be in identifying the measures that could be effective in achieving your objectives and avoiding your constraints. At this point in the risk management activity, you should not be bound by authority, funding, or anything else. This is the time to think broadly about solutions. If you happen to be in the public sphere and you need a specific authority to implement different kinds of measures, don't worry about that. If you come up with a good idea, if you identify some good measures, you may be granted a new authority to do that. There will be things that will limit what you can actually do. But at this point in the risk management process, there should be nothing that limits what you think. In order to understand some of the structural measures for our ANS risk assessment case study, we're going to briefly consider how locks operate. Locks are usually accompanied by a dam. A dam would be built across the river for any number of purposes. One of them might be to make the upstream end of the dam to make the water deeper so that it would support navigation. It could be for hydropower or for any other number of purposes. Once you build a barrier across a river like that, however, you need to provide a means for navigation to bypass the dam, and that would be a lock. So here we have a simple representation of how a lock operates. On the left-hand side, you see a towboat in red and white. You also see upper level. Notice that the water level there on that side of the dam is higher than the water level at the far right. So what we want to understand is how does a vessel navigate these two different levels of water. Well, what happens in the top picture there, notice that the upper gates, shown in amber, are open. So that towboat is going to sail into the lock chamber, and it will be at the same level that it begins, on the upper level. While the boat is in the lock chamber, the gates on both ends are closed and water is pumped out of the lock. This takes us to the middle picture. Notice how the water level has fallen. To the left of the upper gates, we have the deep water. To the right of the lower gates, we have the shallower water. So water continues to be pumped from the lock chamber until the level of water in the lock chamber is equal to that beneath the lower gates, as shown in the bottom picture. Once the water reaches that lower level, the lower gates are opened and the boat can now move out. The process is repeated, of course. If a boat approaches from the right-hand side, the lower end of the dam, it sails into the lock chamber and water is pumped in until it reaches the level of the upper gates, and then the gates are open and the boat can again sail out. That's going to be a little bit of important background, but enough said about locks. Here's why you need that information. One of the structural measures considered by the Glimmerous team was something called a Glimmerous Lock. The first picture on the left shows you how a Glimmerous Lock is laid out. Notice the lock itself. You have two sets of gates and a lock. Next to the lock is an aquatic nuisance species treatment plant. We'll say more about that in a subsequent slide. Downstream of the lock is an electric barrier with a control house. So a Glimmerous Lock has an electric barrier, a treatment plant, and a lock. Now move to the picture on the right. This is the Glimmerous Lock itself. Notice that a towboat is approaching from the right. The water surrounding that towboat is green. It is untreated water that might contain some aquatic nuisance species. As the boat enters the lock chamber, however, notice the numbering system there. ANS treated water from that treatment plant is pumped into one end of the lock. Untreated water is pumped from the opposite end of the lock. This process continues until treated water replaces the untreated water. That brings us to the bottom figure there, where all the water in the lock chamber is blue, meaning it is all ANS treated water. Once the water is replaced, then the vessel can move through the lock, just as we described earlier. So a Glimmerous Lock would be an example of a structural measure, something that would take substantial construction effort and expense. It's the risk manager's job to assure that the risk analysis team or the risk management team thinks as comprehensively about the number of solutions as they possibly can. So in addition to the lock, we have other structural measures. There's the electric barrier. One is already being used in the Chicago area water system. And then you have the A&S treatment plant process. The details are not so important to us. What is important is for you to understand that so far we've identified more than 90 different technological solutions and a number of structural solutions. So far they include locks, electric barriers, and treatment plants. In addition, screened sluice gates were identified, and the figure on the right shows a variety of potential locations for one or more of these structural measures. So the idea that I would like you to have at this point is that under the risk control responsibilities of the risk manager, identifying potential measures is critically important. Those measures should be chosen according to their ability to help you meet your objectives and avoid your constraints. You can think of the individual measures as building blocks. These are the materials that you use to construct a plan. So as the slide here suggests, by assembling different measures in different formations, you can identify different risk management options, different ways to meet your objectives, avoid your constraints, solve your problems, and attain your opportunities. Now, I've chosen these case studies that we have because I want you to understand that people really do this stuff. In the Glimmerous study, they identified 8 alternative plans. So they took those structural and technological measures and they combined them in ways that developed 8 different plans. You see here they used some specific strategies to develop plans. One strategy was a non-structural plan. What could they do quickly that might help to control the aquatic nuisance species? And they realized that education and outreach, pesticide use, and mechanical removal are things that could be done without constructing any kind of measures. But if you read the other strategies, you'll see that they combine structural and non-structural measures. Early in the class, we talked about the different dimensions of risk that you should understand. There's the existing risk. You implement these measures that we're talking about here, and some risks remain. That's residual risk. But your measures themselves could create new risks, or they could transform risks, or they could transfer risks from one location to another. So another important part of this Glimmerous plan was the mitigation. This was the plan's efforts to try to reduce or control to some extent risks that were created by the solutions themselves. Here's a summary of plan number 3. All of the images you've been looking at can be found in the reports that are available in the case study materials. On the left, you see a summary of key structural elements. There are 2 Glimmerous locks, 2 electric barriers, 2 treatment plants. When you look at the map, you can see the locations of the Glimmerous locks. There are also reservoirs, and these are all part of the mitigation. So, what we've been looking at is the formulation process. You begin with your objectives and constraints, you identify measures, you take those measures and you build risk management options or plans from them. You build enough plans that you have some choices. Some plans will be more expensive than others, some will reduce risk more than others, some will be socially acceptable more so than others. But this is a very important part of the risk manager's responsibility to see that this kind of thing is done. And I want to repeat an idea from earlier. There will be things that will limit what you can do in reality, but nothing should limit what you are thinking at this point in the risk management process. Before leaving this topic, I wanted you to see the Vibrio parahemolyticus in oyster risk assessment model once again. You may recall that the green column models the eating occasion for one person under existing conditions. So this is what we would call the without condition in your textbook. This is the situation, the risk situation that occurs without any new or additional risk management measures by the risk managers. And that is contrasted with the with condition. This would be examining the same risk, but with measures in place. So in this particular risk assessment, we are looking at 3 different risk management measures. In column G, you have a heat treatment. That's basically cooking the oysters is the risk management measure. In column H, we have a freeze treatment. That would be to freeze the oysters to halt the growth of the bacteria, as opposed to heat treatment, which is a kill step. And then there is the rapid cool mitigation option in column I. That is also to reduce the growth of bacteria and to hasten the die-off of them. In addition to these, what's not seen is that there are options, risk management options, for restricting the time of year and the location of harvest. So in both risk assessments, we have a variety of risk management measures for the risk manager to choose from. This is a very important part of the risk control step. If you have any questions about formulating risk management options, please feel free to ask in class.